Hello everyone. This MQ is a practice question for Unit 9.8 Galvanic and Electrolytic cells. So let's start and read the question first. The question tells us that a sample of silver is going to be purified by a process called electrorefining. The goal of electrorefining silver is to purify it by transferring it from an impure source to a pure form. In this case, the impurity we are dealing with is gold. So the impure silver is then made into an electrode. And the question is asking which of the following is the best way to set up the electrolytic cells. Now, before we look at the answer choices, let's quickly remind ourselves of the differences between a galvanic cells and an electrolytic cells. A galvanic cells is spontaneous, meaning the reactions happen on its own without needing any external energy source. An electrolytic cells, on the other hand, require an external power supply to drive the reactions. And that's exactly what we have here, an electrolytic cells. So we have four choices. A, we have an impure silver cathode and an inert anode. And B, an impure silver cathode and a pure gold anode. C, a pure silver cathode with an impure silver anode. D, a pure gold cathode with an impure silver anode. So to figure out which one is correct, we need to understand exactly what is happening inside the cells. So let's say this is our cells. So our cells will look like something like this. On one side of the cells, we have the unimpure silver, which contains gold mixed with the silver. On the other side, we have pure silver electrode. Now, before we decide which electrode is an anode and which one is a cathode, we need to think about how this impure electrode, which is a mixture of silver and gold, will actually behave in the electrolytic cells. To purify the silver, we need to dissolve it into the solutions as ions, which can happen by oxidation, of course, and then deposit those ions back onto the pure silver electrode. But how does that work when we have two different metals mixed together? So the key here is gold is much less reactive than silver. So when oxidation happens as the anode, silver oxidizes much more easily than gold. Silver dissolves into the solutions while like this, while the gold simply doesn't oxidize, so it stays solid and fall off to the bottom, as we call it anode slag. So the oxidation half reaction as the anodes look like this. Ag solid become Ag plus 1 aqueous plus electrons. So the silver atom loses electrons and becomes silver ions in the solutions, as we have here. We know that anoxidations happen at the anode and electron flow from the anode to the cathode. So if the impure silver is our anode, then the pure silver on the other sides will be our cathode, where reduction takes place. So those dissolved silver ions then travel through the solutions and get deposited onto the pure silver cathode through the reduction half reactions here, as we have it, Ag plus 1 and plus electrons will become Ag solid. So the pure silver electrode gradually grew as more and more pure silver is deposited onto it, and the gold is left behind at the bottom. That's the whole point of the electrorefining. So putting it all together, the impure silver has to be anode because that's where oxidation and dissolving happen. And the pure silver has to be the cathode because that's where pure silver is deposited. So that gives us the answer C, a pure silver cathode with an impure silver anode.